Chapter 1, Section 5, Applications of Vectors and Matrices. As the final section of the introduction, let's see how vectors and matrices can be used in data science. First, let's understand the multiplication of a matrix by a vector. The multiplication of a matrix by a vector is a fundamental operation in linear algebra. Now, let's understand how this operation works. To multiply a matrix by a vector, the number of columns in the matrix must equal the number of elements in the vector. Suppose we have an m by n matrix, M, and an n-dimensional vector, V. In that case, the product mv is an m-dimensional vector. We should know that the multiplication of a matrix by a vector results in a vector, not a matrix. Here is how the operation is carried out. Each element of the resulting vector is the dot product of the corresponding row in the matrix and the vector. In this dot product, we multiply each element in the matrix row with the corresponding element in the vector, then add up these products. Let's illustrate the process of matrix-vector multiplication with an example. Consider a 2 by 2 matrix M and two-dimensional vector V. To compute the product MV, we compute the dot product of each row of M with the vector V. The dot product is calculated as follows. For each element in a row of the matrix, multiply it by the corresponding element in the vector V, and then add these products together. So, for the first row of the matrix, we have 2 by 2 plus 3 by 3 equals 4 plus 9 equals 13. It becomes the first element of our resulting vector. For the second row of the matrix, we have 1 by 2 plus 4 by 3 equals 2 plus 12 equals 14. This is the second element of our resulting vector. So, the product MV is 13, 14. We can extend this operation to matrices and vectors of any compatible dimensions. For example, suppose we have an m by n matrix and an n-dimensional vector. In that case, the result will be an m-dimensional vector. Keep in mind that this operation only makes sense if the number of columns in the matrix matches the number of elements in the vector. Vectors and matrices are foundational elements for representing data in data science. We can use vectors to represent a data point in an n-dimensional space, where each element of the vector is a feature of the data. For instance, in a dataset of employees, a vector could represent a single employee, where each element might corresponding to a characteristics like each employee's age, tenure, motivation score, and so on. Matrices, on the other hand, extend this concept by representing multiple data points together. Each row in the matrix could represent a data point, and the columns corresponding to the features of the data points. It is a typical way to represent data in most machine learning algorithms. In machine learning, vectors and matrices play vital roles in designing and implementing many algorithms. They are essential in representing both the input data and parameters or weights of the models. Let's take an example of linear regression, a fundamental algorithm in machine learning. In linear regression, the relationship between the input features and the output is modeled as a linear function. If you have multiple input features, the input data is represented as a matrix, where each row corresponds to a data point and each column corresponds to a feature. The model's weights or parameters, which quantify each feature's contributions to the predicted output, are represented as a vector. The prediction is then computed as a matrix vector product, a compact and computationally efficient operation. So, if we want to predict each employee's performance using these input features and weights, the linear regression model can be represented as this matrix vector product. In essence, by using vectors and matrices to represent data, we can perform efficient computations on our data using the principles of linear algebra. Thank you for watching. Please thumbs up and subscribe to my channel.